Okay guys, we are starting the stream again. Just came back from the wedding, time to do some serious work until the midnight. Let's continue analyzing the data. We got to Russian language. We're trying to analyze and find outliers as a function of line length. And we're trying to find super long sentences and see what's the conclusion there. So far, it seems most of them were coming from mined datasets like Vick Matrix, JW, etc. But let's see whether we can figure out something else. Any more insights we can extract would be valuable. So let's continue with Russian. This is where we stopped, basically. Let me see, we got to set the threshold to 20,000, and now we're extracting basically some sentences. So let's first analyze this sentence we have here. Let's see whether there is any additional insight. This actually looks like a decent... Good morning, Sergey. Welcome to the stream, man. Let's see whether there is anything interesting in this quote-unquote sentence. This is flagged as a sentence in our translation dataset. It looks like some type of a list of bunch of names or something. Doesn't look like a actual cohesive text. Somebody who speaks Russian can help us understand what's going on there. Although for these things we could also use just Google Translate, the free version, I guess. But then we probably have to chunk it into sentences. So better to just find a native speaker. Let's continue. Let's hit F5. Let's find the next outlier. Okay, here is the next outlier, 21,600 lines. Let me find this. Control G, paste in the line number. Here it is. Let's grab this particular sentence and try and grab the letter Z. That's Z in Cyrillic. Let's paste it here as the second example. Second task is gonna be here. And again, this looks like some type of list enumerating places or something. Just skimming through it, that's the feeling I'm getting. Let's see. Let's just grab some of these questions like this. Let's go back to Russian. Here we are. Paste this. Is in Russian. Cyrillic. Okay. And then the second one was here. Second task is this one. Okay, let's continue. Hit F5. Find the next outlier. Again, 20,300. This might be the same type of a sentence. So let me just double check it. But if it looks the same, we will not extract it. Looks fairly similar, but let me paste it as a third task for Russian here. So third task. What is this text about? And let me go up there and say we are looking for people who also speak Russian. Before Russian, we had what? What was the last language before Russian? Let me see what this one was about. Second task, Malayalam. Let's go up there and put it here. Okay, Malayalam. And then above Malayalam was, let's just grab the name of the language. This one was fairly lengthy. Looks fairly repetitive as well. This one was Tamil. And then the next one was Marathi language. Okay. Marathi after Tamil. And after Marathi, I think it was Bengali. Okay, we actually have somebody for Bengali, so we can reach out. Let me just add this as a task. Reach out to our champions and tell them about the new language tasks in the document. Okay. Again, let me go back to the text. So after Bengali, we had what? After Bengali, we had Telugu language, and I think we did no double. Okay, so this is it. Let's continue. Let's go back to here. Did I paste the third task in Russian? I think I did. Let me just double check. Yes, we did. Going back to the code, hitting F5. Let's see. This outlier, 31,000 characters for this particular sentence. This looks very similar to the previous one, so I will not. Maybe let's just copy paste it, but I'm gonna delete it immediately. Let's just see what it's about. Okay, looks very similar to all of the previous ones, so we can ignore it. Let's go back. Let's see whether we have any more outliers. Okay, here it is. 32,000. I'm just gonna hit F5 because it looks suspiciously similar to the previous one. 22,000, again, suspiciously similar to the previous lengths. Hitting F5 again. Let's see this one, 24,000. Let's just quickly check whether this looks the same. Yes, it does. Going back, hitting F5. And we might be, this might have been the last outlier. And after Russian, we can transition to other languages. Okay, what's the next one after Russian? We are left with Turkish and UZN, whatever the language is, I always forget. Let's see. Turkish. Let me just wait for the Russian to complete. After this analysis, we will do analysis of the duplicates in these languages, and then we can transition to the filtering stage. So that's the plan. Let me think whether we want to do anything else. We've seen the number of sentences per language. We've seen the number of sentences per language direction. we've seen the line length distributions. And that's what we're doing right now. We are basically analyzing some flagged languages that came up during the line length analysis. So after we wrap up this, we can just transition and do the duplication analysis. Okay, so here's one more outlier. Sergey, what's your native language, by the way? Let's see what this is. All of these look, I think they always start like Ukaz Prezidenta Republiki Uzbekistan. This is something to President of the Republic of Uzbekistan. It's always the same sentence for these outliers in Russian. Let me hit F5. Okay, you were raised in Canada, nice. I thought because of your first name, I thought maybe you might have some Russian heritage. Okay, again, 20,000. These are all these all look like duplicates. Let me hit F10 again. And same here, 24,000. Let's hit F5 until we don't have any more outliers in Russian. Okay, this one is 31,000. Let's see. Oops. Same. President Republic of Uzbekistan. Okay, let's continue. Continue. A ton of sentences that have similar content in Russian. Let's see. For some reason a bit slower. Probably these files are very, very large. Yes, I think we can continue here as well. Let's go. This is probably the last one, or maybe there is one more. Yeah. This might have been the last one. Yes. Nice. We are done. Stopping the analysis of Russian. And let's go to the next one. Turkish Latin. Let's go up there, reduce the threshold to 2000, remove the breakpoint and put the breakpoint somewhere here exactly, just to see what's the range of the outliers in Turkish. I wouldn't be surprised it's very, very similar to Russian, because there seems to be a very big parallel corpus between Russian and Turkish. So if we see 20,000, 30,000, those similar types of line lengths, then I highly suspect that's gonna be just a translation. The numbers might differ a bit because we are using the length factors to multiply and normalize them into the English characters. So, but let's see. Let us see what we get as the result. Well, actually, that normalization should make it so that we always end up with similar numbers. Let's see. There is obviously a ton of duplicates, sorry, not duplicates, still outliers. I see here a lot of printing with over 2,000 characters. Almost done. When you say kind of speaking Russian, like can you actually read? Can you help us out with these tasks potentially? I'm not sure whether I saw anyone put Russian here, or maybe I'm mistaken. Let's see. No, I haven't seen Russian. Okay, so the outlier is 25,000, 25, 32, 32, 6 million, 6. Okay, these are all the same. Maybe these with 43,000 might be interesting. Maybe those ones might be interesting. Okay, let's check one with 25 and then let's see the one with 43. So 25, for that I'm gonna make it such that we have 25 here and 20 here. And then we're gonna include if line is above. Okay, if line is above the, let's make it like between this lower threshold and upper threshold. If that's the case and it's verbose mode, in that case we hit the breakpoint. So let's just grab the 25,001. Something like this should catch those. Let's just copy down and hit run. You're trying to look through the Russian corpus right now to see feasibility. Some of the words are definitely above my reading level in Russian. Yeah, no worries. No worries. Check out the document. Maybe if you can see anything interesting here. So let me send you the document if you don't have access to it already. Check the Russian task in the bottom of the document. Okay. Analyzing Turkish. Okay, let's see until we hit, okay, here we are, hit F10. So this one is 25,000. Let's just grab and copy, and let's go here and open the file, super large file. So I suspect this is TIL as well. This might be just a translation directly into Turkish. So if we see something that looks like Uzbekistan or something, we can use Google Translate as well. Then we know it's the same sentence, guys. But it's not, apparently. So let's grab this one. Let's go to the bottom. Let's insert a line, and let's say Turkish, and let's give that the style of heading 2, and then let's just print this. This definitely looks completely gibberish with a ton of symbols. So I'm just gonna delete this one because it's completely pointless. Whoops. Hit F5. Let's hit the second outlier. That's 25,000. See whether they're the same. And then we're gonna hunt for the 43,001. Okay. Let's go back to the analyze data. Waiting to hit the breakpoint. It's progressing. We're almost done here. Hi AI genius. I'm poor, but how can I be rich? Have any suggestions? I'm not sure whether you're trolling me, but I don't have the answer to that question. Okay, 25,000 lines, 1.87 gigabytes, snap. We managed to crash. Nice, we managed to crash the whole system. So maybe what we can do is just quickly stop appending the actual lines and instead just focus on this. And also one more hack we can do is if I smaller than 500, let's continue to speed it up because, well, actually that will, yeah, let's try that. And let's rerun. Couple of optimizations. Just to go faster until 500. And now it's gonna start analyzing the lines. Oh snap, we actually didn't hit anything, so that was a bad optimization. Let's stop this. For some reason we've missed. Okay, let's see the one that has over 40,000. And let's run this again. Turkish. Let me just put this task here. So these are the tasks for this stream. Wrapping up the line length. While we are waiting, let's see. We have a couple of languages here that we need help with. Let's see who speaks Turkmen. Nobody here. Canada. Nobody. Punjabi. Nobody. Telugu. Nobody. Bengali. Okay, somebody speaks Bengali. Let's ping this person. Let's see whether this guy, and we have somebody on Discord as well. Let's see whether they speak, whether they can help us. Siddhartha Mitra. That person did not leave the Discord link. Let's just use this Discord handle here. Okay, but they're not in the server. So we have to somehow enforce these people to join the server, otherwise it's hard. Just writing down, just DMing this guy. Okay, Bengali. Okay. And then Marathi. Nobody speaks Marathi. Tamil. Nobody speaks Tamil. Malayalam. Nobody speaks Malayalam. And Russian. Interestingly enough, nobody used Russian. Nobody signed up for Russian. Okay, let's see how we are progressing here. We are looking for this outlier with 40,000 plus lines. Still didn't find it. Okay, I don't understand. Why are we not hitting? There should be a number with, there should be an outlier with 43,000. Yet we are not hitting it. So let me see. Oh my god, oh my god. I messed up here. Lower should be 40,000, the upper one should be 46. So just stop this and rerun it again. Hey Sergey, no worries, man. Take your time, only if you can, only if you're comfortable in the language. Taking a bit more time. Let's make it clear here. Okay. So here is the outlier. Copy. Please don't crash. TIL, English, Latin, Turkish, Latin. Okay. Let's go. Here it is. Turkish. Okay, a ton of URLs, guys. Just a ton of URLs prefixed with a small snippet in Turkish language. So we can ignore this. We can just delete the redundant parts and leave that person to maybe help us with just this initial part. And let's just copy the actual task. Third, second, first task. Let me just copy paste this. Awesome. Turkish is in Turkish. Turkish Latin script. Okay, and let's find some smaller ones. Let's maybe find certain outliers between like 10,000 and 3,000. Let's just grab one of these smaller examples. Just looking for insights. What's the content? Like, does that look like a reasonable piece of text? Is it cohesive? Is it actually in Russian? What's the, can you infer where the, I think a good example of how this should be handled is Amrit. So he handled Hindi in a very, very good way. Let me just show you the example. I think it was data analysis somewhere. So here it is. I sent him the message with this super long text, 35,000 characters, and he came to me and said the following. Looks like some kind of translation. Literally says, okay, that was me. Analyzing something looks off, definitely not normal. This seems to be the 5th chapter of religious text, Quran, called Al-Maidah. If you closely look at this file, there are numbers corresponding to 120 verses. This is the 5th chapter of Quran with 120 verses. This is mostly mined from this page. And then he literally found the page on the internet. So that's a good example of how I'm expecting people to handle this. seems they are religious texts where the entire chapter has been put into a single file. Let me just take a snapshot actually of this. And let me share this with people. Okay. Let's try and partition this into first 20. And then line lengths, these indices. Let's do string. Why am I not seeing anything? Set k to 20. Oh, I think this might be stuck. Let's see. This code might be stuck. Okay, here is the result. Okay, there is a ton of outliers in Turkish, apparently. Let's try first 50. Might take a while to compute this. And then what we're looking for is to just print this. Let's grab some of these between 16,000 and 20,000. 60, 20. Okay, we run. Yeah, no worries, Sergey. Thank you for the help and for being here. Can we somehow make this faster? Taking too long. Maybe we can somehow chunk the file to read it in parallel. Would be 16 times faster if I split it across 16 CPUs. CPU cores, I mean. Okay. Let's see. Here's the line number. Here's the file. Let's move there. Exchange. This starts like some English text here. Let's see the whole thing. If we navigate to Turkish language, second task. Okay, again, a ton of text that doesn't look like a proper Turkish language. So I'm gonna remove it. Let's hit one more outlier. In general, the best thing would be if a native could be doing this type of analysis themselves. Then they can literally debug what's wrong with their languages. We'll basically lose all of this text in the filtering stage. Yeah, ton of garbage, guys. This is just a ton of garbage. It's mostly a good heuristic to just filter out all of these texts. Okay, let's stop here. It's mostly a ton of garbage. Analyze data. Turkish. And then let's see our last language. Hit and run. Let's just hit run until we get to here. Okay. There are some outliers above 19,000 and 30,000. So let's just set this to whatever, and this should be 19. So upper threshold 50, lower threshold 19. Set a breakpoint, stop this, rerun the whole script, and hit the print statement. Okay. Here we are. First one, copy that line number, paste it. Uzbekistan Republikasi President. This is translation, guys. This is actually the translation we've seen before. Same one was in Russian, so this is indeed parallel text TIL, same dataset. Let's hit F5. Same thing here. Hit F5, 30,000. This might be the same thing, but let's double check. Let's copy the line number. Let's enter here. Let's hit Control G, find the line. Uzbekistan. Okay, this is the same sentence again. So all conclusions that we had for Russian, everything remains the same for this language. So we can just ignore this. And finally, we are done there. Let's wrap it up. The conclusion is that we mostly do want to filter out all of this data. If it's too long, something is off and it's not a valid sentence either way, so we want to filter it out. Either way, when we tokenize that, we couldn't, it would be too long of a context length for a transformer, so we'd had to split those sentences. So it's definitely not a valid sentence, not a valid piece of bytext. Let's see one more quick analysis is which data sets do these outliers come from? So if we set the lower threshold to maybe say 5,000, upper threshold to maybe whatever, some big number. And if we set languages to none, which means for all of the languages, find these outliers. And basically print in file path let's just extract the data set from the file path. So what we need to do is grab the file, then parent. So maybe we can do, maybe just import quickly pathlib and create a path out of this. And then grab the parent and grab the parent. So this one will be, this one should be good. Okay. So let's see what's the conclusion for all of the data sets. What's mostly the data set that we hit here? Vick Matrix. Okay, and then just how do we grab just a base name or name? We do it like this, what will happen? Let's see. Okay, Vick Matrix. Let's rerun. Let's maybe create set outlier data sets. It's just gonna be a simple set. Maybe do it like that, and then just say add this, and then at the end we can just, here we can print data sets containing length outliers. A better thing would be to create a counter. So maybe instead of a set, we can do from collections, import default dict and counter. Okay, and then we create a counter. And then we do what we just, how does a counter work in collection counter Python? Well, actually, why not just create a default dictionary of integers? And then we can just do for this data set, just do +1. It should start with 0. And then here we can analyze it. Okay, hit run. Let's maybe grab the first one just to make sure it works. Okay, Vick Matrix, hit F5, let it run. Let's see where the outliers mostly are located in. The current hypothesis is they are mostly in Vick Matrix. Okay, it's progressing. Now we're gonna hit some of these slow files because they are like 1.8 gigabytes in size. The progress is very nonlinear when we are going through all of the 726 files. Almost done. Okay, here we are. So mostly Vick Matrix, 231 come from there, followed by JW, followed by IITB, followed by TICO, and then TIL is actually the worst one. And then there's the CVIT PIB. So Vick Matrix and TIL are by far the worst data sets. Okay, that's a valid insight. We can put this in here. This is actually a valuable analysis. We can just leave it in here. Okay, guys, save this. Let's make a note about this. So Vick Matrix and TIL are the worst ones. Length. Outliers are Vick Matrix, JW, TIL. Okay. Let me commit the changes here. See what we've done. Language code mappings. What did we change in there? Okay, just a bit of additional text, better commenting. Let's see, analyze data and notes on languages. Those two are fine. Let's just see the notes. No, let's see the analysis data sets. Analyze data script. Let me stop it. Do a diff. Okay, we want to change this to upper should be maybe 1050, the same as in the paper, and this should be 5. Okay. Let's see what else. We've added this additional branch. All of that is fine. We can delete the to do. And we are done. Okay, let's submit those changes. Add the README, add the analyze data script, add the language code mapping script. Enter. Nice. So these were some languages that were the most impacted by filtering, but that has more to do with the duplicates analysis rather than anything else. So let's go to the notes on languages. Let's create another section called duplicates analysis, and then we can put the languages the most impacted by duplicates filtering in the filtering pipeline are, and then we can just log these. Okay. Before we continue to the duplicates analysis, I just want to make sure this makes sense for people who just come to this channel. To this document, they need to know what to do. Here, read this first. So first prerequisite is you're a native speaker of the language. Let's see what's my handle. What's my handle on Discord? Is it just my name? Let's see somebody else's handle. I guess Amrit also has his name. Let's see whether Robert. Okay. Okay. Let's go. Let's go and do the duplicates analysis. So that means here we change this to dedupe. And we want to understand how many duplicates each of the data sets has. That's the goal. Each of the corpuses for each of the, doesn't want to say, I keep on saying corpuses, I hate it. Is it corpora or corpuses? Corpora versus corpuses sounds like corpses. Corpuses. How does one say this? When should I use corpuses or corpora? I keep using both. Okay, corpuses can actually be used, but corpora is preferred. Anyhow. Dedupe, we assert that there is a single language. We want a single language analysis. And then we're gonna hit this branch. We don't need either of these two. So this should be fairly fast. This whole loop should be fairly fast. Then opening it up. Well, this will not be super fast. Let's see. For now, we don't need to have the guardians. We want to do for everything. Let's quickly do it like that. So just open up the file path and then do the filtering and then add the duplicates count. We want to do that for all the language directions. So we go through the data set. We find the files. And then we grab the two files, which means okay, just a second. File 1, file 2. Hey Robert, it's going nice. It's going good. We've been doing, we automated download of all of the datasets, including NLLB seed. We've done some cool analysis using line lengths. We found outliers across different languages, and now we're doing some deduplication analysis. Just thinking what's the best way to go about this. I want to create another dictionary object, basically. That's going to tell me everything about duplicates. So something like this, and then language code 1, language code 2. So I think what we can do is exactly this. And then under dedupe, we don't need this assert for now. We just need to print this. And we also don't need this can actually delete this whole thing. And we'll keep it like that. So, for each of the legit files, we iterate. We get the language codes. Is there any mention of direction here? Okay, there is it here, language code 2. So we do the same thing here. We just want to keep on adding these. Okay, this looks legit. We just want to remove the number of sentences from the features. Let's just focus on deduplication. And languages, we can specify just none because we don't care. And let's kick it off. This should be everything we need. I'm just thinking whether we want to do for language duplicates. Actually, we just care about pairs in the filtering stage later. So technically, we don't care. We just care about direction. And we'll keep on. A single direction might have multiple datasets associated with that language direction. So we might be adding a couple of these. We might be hitting the same key multiple times. That's fine. I don't care about direction corpus. I care just about direction. So I can do like this, and let's hit this. Let's see how fast this is. Okay, found duplicates. This might take a while. Every time we do this, we have to instantiate a new counter and a new filter, because these are stateful and they are internally, basically they have an internal reference to a set, so that they can add different hashes, and using those hashes we figure out what are the duplicates and what are not. Okay, let's see how this is going. I would also love to know duplicates per dataset. But for now, let's just see how this is going. Okay, Sergey sent me a message on Discord for Russian. Okay, sorry, I didn't see the... Just address some messages here. Okay. Yeah, I see. I see your handle is potato. That's cool. Let me see. Are you comfortable with me sharing the message on the screen during the live or not? Let me know. We can go through it together. If you're fine. Okay, awesome. Okay. So they are apparently all from this Lex, and this looks like some government domain, like Uzbekistan or Russian or. So it's this document. Yeah, it definitely looks like. I do notice these symbols here. I saw those before. So it's probably just scraped from this document or what? Decree of president, people, names, departments, job titles. Makes complete sense, man. Can't tell if it's official government website, but seems very governmenty. All three are extremely related to this exact thing. Yes, makes sense. Okay, so that was scraped. What was the data set that this was? I didn't write down the data set that we found this in. Probably just mine data, apparently. Makes sense. Thanks for doing this, man. Maybe we can quickly go there. Was that the first one or the second one, or all of these? All three tasks, right? You said, I think all three tasks are from the same source. Got it. It's all three. Makes sense. I'm just gonna make a note there instead of deleting it. Makes sense. Okay, this is going super slow because this is a fairly intensive task. I think we're almost done. We are almost done. I've seen, okay, 722, 726. We're probably at the very end of this processing. We'll soon hit the breakpoint and then we can do some analysis there. We can dump this dictionary so that we don't have to rerun this again and again. What should be our data set for evaluation? What did they use for evaluation during the training? Validation. Validation set. Validation perplexities with various dropout strategies for low resource direction in the top row and high resource direction in the bottom row. On which data sets do you do that? Should we use Flores 200? We can do that. We have Flores 200. Validation performance of low resource bilingual models. For each direction, we report figures for the model trained on public bytext and on the combination. Is this like a average across all of languages, or actually not? Because these are bilingual models, so they are testing on I guess only particular directions inside of Flores 200. Okay. To assess the performance of NLLB 200 on domains other than the Wikimedia text of Flores 200. So Flores 200 is going to be one of our data sets, but we are also going to use some of these. Total of 238 directions from 8 benchmarks. Okay, fair enough. So one of the answers is going to be Flores 200. See? Okay, let's go back to this page. Let me first just see what other mentions do we have here. Okay, they also have this NLVMD dataset. I'm not sure whether this one was released. Okay, and whether it lends itself to the common strategy of single task fine-tuning with small quantities of in-domain high-quality translations. That's what they use this dataset for. We experiment with the NLLB MD, high-quality translations in 4 domains, translating from English to 6 languages. We hold 500 sentences in each language for testing, fine-tune on 2000, and use a reminder for validation. In each translation direction into and out of English, okay. Okay. We don't care about fine-tuning. Is for toxicity. And then we further subdivide each of these into out of English and non-English centric. We'll check it out, Sergey. Thank you. Okay. We evaluate on 201 English from English into non-English direction. Okay. Okay, we're gonna check these pages here. Results. Okay, this looks like the most important part. Shumato dataset. Okay, let's go to page 109 or 108. Public benchmarks. Let's kind of skim through this while we are running the duplication in the background. It's fairly slow. We use publicly available and widely used MP evaluation benchmarks to assess the performance of the model on domains other than Wikimedia. Okay. 238 directions. How many directions are we We have roughly, I think, around 200-300 as well. If we go up here, 213. But that's only for the primary dataset, obviously. Oops. Let's open up the paper. We describe each of these benchmarks and the set down below. How often do they compute this during the training? What would be a reasonable assumption? Do we just want to test for Flores 200, or do we also want to occasionally check our performance on these? This overlaps with the 10 languages selected, and both are frequently used for benchmarking MMT models. Okay. Let's note down these somewhere. Let me just extract this here. So I can write it down. Flores, WAT, WMT, IWSLT, what does the pre-training side of model structure look like so far? I'm not sure what you mean by that question, Robert. Can you clarify? Psycho. Mafand MT, African News Corpus that covers 16 languages. 8 of them are paired and 5 other languages are paired with French, for a total of 26 directions. Then there is the Outsumato, for South African languages, consists of 500 sentences from South African governmental data, translated separately by 4 different professional human translators for each of the 11 official South African languages. 9 of these languages are covered by NLLB 200. There is no standard valid test split, so we use the first half for validation and the second half for testing. Okay. Madar. Yeah, this is, this is just preparing data for training. So how does it look? We're gonna do the duplication analysis and then filtering and then data preparation stage, which includes sharding, includes binarization, deduplication on a global level, as opposed to here. In filtering stage, you just do for every language direction for a particular dataset, you filter the duplicates. During this second stage, we do the global deduplication across the whole language direction. So we have to, we kind of went through all of that. We're not now just robustifying, getting more insights, but we can already kick off a run, and we did a couple of days ago, actually. We kicked off a successful run. We need to see how to implement the 4-stage curriculum they mentioned in the paper. Okay. Okay, so they use these 3 metrics, blue, SP blue, and this one. We first tokenize the hypotheses. Then for each evaluation corpus and for each language, we conform to the tokenization normalization used in the current state of the art. Okay, table 56 quickly. Evaluation details for irregular directions in public benchmarks. Let's see what these are. Let's get back here. And then the results, table 35A. Eight directions, published numbers, and here are their numbers. Okay, these are very low blue scores. Okay. 12 high resource languages paired with English. I'll perform state of the art on 21 out of 24 directions. Okay. Table 37, Tycho. And those of the best baseline trained in that original paper, we see a considerable gain in accuracy on low and high resource language alike. Mafand. We evaluate on datasets with non-English centric pairs. Madar for Arabic dialects. And Ashmato for African languages in table 57 and 58. Okay. And finally, these are some fine-tuning results on this NLLB MD dataset. Let me just see how this section, what's the name of this section? Public benchmarks, out of domain generalization, performance on non-Flores domains. Let's quickly skim this as well. Couple of pages here. So they fine-tune on a single task for 50 updates, which is 15 to 20 epochs, with a learning rate, blah, blah, blah. 2 options with the original training objective, without any regularization as the second option. Okay, and then figure 38. Okay, here this is done. Let me just put it on hold for a second. Well, to prevent too much context switching. Figure 38 shows validation scores in the chat domain of the pre-trained NLLB 200. Okay. Okay. So again, I guess nothing super surprising there. They fine-tune, they get a bit better scores. The issue of fine-tuning sparsely model has been raised before. So this is again a mixture of experts. We are using a dense checkpoint. Okay. Okay, plus fine-tuning and load balancing. Sounds good. Let's go above here. Before these, what was the analysis before this? Performance on non-florist domains. Let me just see in the table of contents here. Do they share this multi-domain dataset? Maybe it's mentioned here, or maybe it's not. Avoiding overfitting and achieving strong out-of-domain performance remains a major challenge in NMT. Does fine-tuning on high-quality in-domain parallel text lead to good performance? Okay. Along with 5 low-resource languages, we also choose to include 1 high-resource language to enable comparisons with other models and datasets. We chose low-resource languages related to other high-resource ones. Hide the unknown. Enable future studies. Okay. Domain selection. Voice problem. Do you hear me? We translate the English side. Awesome. Thank you, Sergey. Okay. They don't mention anything about releasing this one. It's not working for you or what? What exactly is not working? To summarize, Flores 200, which enables reliable evaluation of over 200 languages, is critical for ensuring the quality, blah, blah, blah. Finally, we utilize NLLB MD to measure the generalizability of our translation models across multiple domains. Now that we have described the creation of 3 human translated datasets and their uses, we visit how we acquired training data for our efforts in the subsequent section. Okay. So nothing is mentioned there on the topic of where can we find the NLLB MD. These 2 are open. I did download Flores 200. We do have NLLB seed, so that's fine. Mining, modeling, evaluation, automatic, bringing it all together, results on Flores, analysis of NLLB. Okay, so I guess just curious to see a bit more here. Let's just see whether they mentioned how and whether they run evaluation during the actual training, just because there's 40,000 plus possible directions. How do they, what's their strategy there? How do they track the progress on Flores? Read section 8.3, results on Flores 200. Okay, we present the results comparing the performance against existing state-of-the-art models. focusing on English-centric, non-English-centric, and zero-shot performance. We follow this with a human evaluation on NLLB 200's translations on Flores 200. And then they discuss the toxicity. Okay. So it outperforms some of these baselines like M2M100. The results show that NLLB 200 improves upon state-of-the-art systems by a significant margin, despite covering 200 plus languages, twice as many languages, compared to any previous work. Those results are shown in these tables, I guess, here. Okay, and then they compare for African and Indian languages. Okay, again, it outperforms. This one was fine-tuned, I think, on this Mafanda dataset. Compared to two recent works, fine-tuned on the Mafand MT dataset. Okay. And then so that was for African languages, and now they check for Indian languages. Indic Trans, Indic Bart, commercial translation systems, Google Translate, blah, blah, blah. Indic Bart reports scores with the default 13A Moses tokenizer. On table 32, we observe that it outperforms all the models significantly on the into English directions, and from English into the non-English language performs better than A and B, but worse than commercial systems. And arguably, you care more about translating from English into that language, because those people care about grabbing a piece of text in English and translating into their own languages, obviously. So overall, on average, it outperforms all of the above systems, but again, that's not what most people would care about, right? So NLLB 200's training dataset includes 25 Indian languages, which is almost twice the languages covered by A and B. These baselines up there. Okay, they attribute this to just more languages being supported, so some transfer learning plus mind and back translated data quality for the Indian language family. Okay. There is 40K combinations on Flores 200. They categorize results into 3 buckets: high resource, low resource, very low resource. And then they further divide into English and out of English and non-English. Okay. English-centric performance. On average, into English is much better. Okay. Okay, nothing super insightful on these pages. On the subset of the new languages, achieves 39.9. And then non-English comparison against Google Translate, and then human eval. We added non-English centric mind by text data to our dataset. Further, we carefully choose the mind by text directions which have better aligned by texts and are from languages which are similar to each other. Okay, let's quickly see comparison against Google Translate. We focus on our observation on low and very low resource language directions that overlap between Flores 200 and the Google Translate API. Note that the NLLB 200 covers far more languages. Table 34 demonstrates significantly outperforms into English, but out of English lags by -2 on low and -1.5 on very low. Okay, they really love saying stuff like overall NLLB 200 outperforms Google Translate by +0.6 on low and +0.9 on very low on average, which is obviously misleading if you just presented it like that, because people care more about out of English than into English. If you're creating a model that's touted as no language left behind, you're trying not to be English centric. Okay. Just see where they mentioned during training. Trying to see how they're running, how often are they testing for these 40,000 language directions. Okay. Data tagging. Outperformance is all you need. Bold numbers is all you need. Okay, nothing super insightful there. We can check for the data sets they mentioned in their public benchmarks, and then we can just figure it out for ourselves how often we want to run it based on how long it takes to evaluate on those. Okay, let's continue this analysis of duplicates. Let me just open up the Notion here. Eval. Training. Okay, let's step over here and let's see what we have here. Duplicates dictionary. Here we can see for each of the directions how many duplicates we have. Let's store this somewhere. Let's just save this as a pickle file somewhere. Do this. Length directions, duplicates, pickle. And next up we dump this particular dictionary into the file, and that's it. Let's just open it up. Okay, it's just let's just save it as a JSON file. Let's just rerun this as a JSON. Just write file and then JSON dump and then what? We want to dump this particular dictionary into the file. Let me see what's the JSON dump Python. What's the syntax there? We open the file, we first pass in that, okay, that looks good. And then let's just put indent like 4. And then we also need to import JSON. import JSON again. Let's rerun this. Okay, and let's see. JSON. Let's just quickly analyze this. Would be cool to filter this, to sort it. And would also be cool to contrast it with the amount of text. Obviously, some of these directions are much more rich in data as opposed to other ones. So this is not full picture until we see the number of sentences. So to do that, we can basically, I don't think we've done that. We didn't pass the feature number of sentences, so we cannot actually, this is empty as you can see. So we have to separately rerun and dump the dictionary that contains the number of sentences for each of the language directions, and then we can have both of these side by side. We can combine them and see what's the percentage-wise number of duplicates for these directions. So let's do that. Let me just stop the run. This was great work here, and now let's just put number of sentences. And that's gonna store us directions as well. Okay. Let's rerun this. This should be much faster. Okay. See? Okay. So let's save. Let's go here. So here we have for language, and here we have for language direction number of sentences. So let's just go and import JSON, and language directions, not duplicates, but number of sentences. And then JSON dump, and then we dump this dictionary, and let's save this. And now we have both of them. So now we can do some interesting analysis here. Let me just delete this pickle file, we don't need it. So here it is. This one and this one. 1 through, okay, we have 94 in total. And wait, these are not directions, guys. This is just language. Wait, what happened here? Oh, I have the wrong one. Let's start this again. Okay. So here it is. For each of the directions, we have 213 directions apparently. I think those numbers are logged somewhere here. 213 language directions. Let's open up the dictionary and let's compare it with duplicates. So duplicates again. Okay, let's now create a simple file to analyze this data quickly. Let's just add a temporary file. We're going to load copy path, duplicates path, and then we need copy path to this one, length, number of sentences, path, this one, and this one. Okay, now let's open them up. Okay, let's import JSON. And let's now go and combine them. Let's just find the percentage. Okay, fair enough. This looks good. So we go through the number of sentences dictionary. We grab the direction, the number of sentences. We grab the duplicates for that direction and see what's the percentage there. And then maybe we can just multiply that by 100 and make that a string. Okay, this should work. I think this is the syntax. And let's just print that dictionary, or we can also just dump it. Save as JSON. Let's go. Dump it. That's it. Okay. Let's go. We don't need any arguments. Save. Why can't I print this? Here it is. Let's dump this as well. And let's open up this one. Okay. So here we see it's always around 1%, maybe a bit more, and then some of them have a bit more. 2.53% of data is duplicates, 5.05 here is duplicates, 23.17, and then 50. Okay, let's try and sort this so we can easily visualize what's going on. So here, hey Nick, I'm not that familiar with blockchain, if that's your question. Let me just read this again, your question. Yeah, I think I heard of the faculty. So you have the option to go to AI or blockchain. Oh, 100% artificial intelligence, man. No doubt about it. It's actually a technology that's producing useful products. Blockchain, we're still waiting for an actual commercial product that global audience will benefit from. It's still very much niche, and in my opinion, I don't want to go into, I don't want to digress into discussing blockchain. I don't think it's a bad technology. I just think between those two, I definitely will go with AI. AI is going to change everything over the next decade. That's I deeply believe that. Okay. How can we sort fair enough. Looks good. So what we do is we grab the percentage dictionary, we grab its items, and then using the value, we sort and we create a dictionary out of that. And now let's see whether this will mess up because we converted into strings with percentage signs. Probably not. Let's just double check. Okay, we have, it's good, but no, it's not good because the dot is ruining everything. Let's not convert into strings. Let's just make it a number. And now this should work. This should now work. And we also want to do key and then reverse true. If we reverse, what's the natural ordering? Descending. Yeah, we want to go descending. Let's rerun. This looks good. Awesome. And now we can just dump this. Let's see the results. Here we are, looking good. Okay, then if that's the case, if it's less about blockchain, more about cross-platform projects, I don't know. It depends on your personal preferences. Like obviously, having a decent software engineering background is a good thing. I think AI is the most promising field still, but having some background in software engineering by doing such projects is probably a valuable thing as well. So it's hard to know without knowing how good the actual lectures are and all of that. There is a lot of caveats, but in general, without priors, I would say just go for AI. Okay, Spanish, and this language has the most duplicates, followed by these: French, English. Okay, let's grab this analysis here and let's copy that into analyze data. Maybe put it in here. Import JSON. And then store it. And then we can delete the actual temporary file here. Let's just delete this one. Okay. And what else do we want to do? We want to see per corpus, per language direction, I want to understand how many duplicates. Actually, I want to understand yes, for corpus, for language direction, what's the number of duplicates? And then from that information, we can always aggregate and get number of duplicates per corpus and vice versa. So that's kind of the most fine-grained way to collect this info. So let's see how we could do that in the main loop here. And that's the last thing we're going to do. And then we can just transition and start analyzing these discrepancies we found in the filtering stage. By the way, guys, if you haven't seen this already, go to our server, Discord server, go to the Open NLLB channel, and you're gonna find a ton of information about the project, and a ton of people are joining as well. There's some pinned messages. You can find everything about the project, about tasks, about the concept of language champions, where you can sign up with your name to help around certain language. If that's interesting to you, check it out. Okay, let's now improve our duplicates analysis. What do we need to do? We need to start logging, not for direction, but also for, we also need to start logging for corpus. So let's create this to be a default dictionary of default dictionaries of integers. And then we can grab the corpus information somewhere here, I guess root directory. Let me just think, where is the corpus information stored here? Is there any mention of corpus? Nope. So I assume that we just need to fetch the parent. So let's see, let's run this. Oops, wrong arguments. Let's put the analyze data config from one.json. And okay, first argument must be a callable or none. Okay, let's just make it a dictionary. Or what can we do here? Okay, we can always do like this. We can always modify the keys such that we contain the information. Okay, let me just rerun this quickly. Where is the data information stored? Once we enter here, the information about dataset is just above the root directory. Okay, so let's then grab the corpus name. Corpus name is this, and then parent of this one, and then grab the name. Yes, I think that's the case. Let's just print that in the debug terminal. Yes. So now that we have corpus name, we can come here and we can do corpus name underscore followed by language code. The difficult part later will be just how to parse this, because of some of these corpus names also have underscores. Let's just see what's the most elegant way. Can we just create a default dictionary of default dictionary, Python? Nested default dictionary, whoops, Python. Exactly. This is what I've been looking for. And we just want an integer here. So this is not callable. That's what he was complaining about before. So now it's going to be elegant. So just grab the corpus name. And then for that corpus name, let's see. Oh, thanks a lot. I think this is the first time somebody sent a donation on this stream. That's nice for you. Just one last question. I'm sorry for bothering. They say that only the basics of AI is taught, whilst the blockchain, at least what I saw, looked modern. You know what's the thing with AI? There is no chance, but I guess it's the same for anything else. There is no chance that you'll have lectures that are that good in your faculty. Ultimately, you'll end up learning the most by going through some of the public courses, or building your own projects, and so just extracurricular stuff. So that's ultimately, no matter where you study, the best type of knowledge will come from probably elsewhere. Even if you were at Stanford for some particular area, you would probably be studying from MIT or whatnot. So I guess if you can self-study, you don't have to really worry that much about picking a wrong option. I don't know. Maybe for AI, you're right. Like, you probably will learn much more by just going through courses yourself instead of attending lectures at your faculty. So maybe you can go with that other one by that line of reasoning. But again, I don't have enough information to tell you without knowing the actual people who are teaching, the actual curriculum, getting a bit. So what I would suggest you do is basically analyze the curriculum, try and speak with people who went to both of those, and that's the only way you can really decide. Yeah, no worries. I mean, I usually reply to people on these streams, so unless they're trolling, which happens. Again, thanks for the donation. That was very kind of you. Data sets. Okay, this should now work. We are collecting corpus name and language code. We should have done this before, but I was not really smart, so we have to start again. Let me see what changes that I made. So we introduced this one, corpus name, remove the guards, and added this additional logging, and all of that makes sense. We can kick it off again. Did I answer your question, by the way, Nick? Try and spend some time doing your own analysis. See, what I would do personally is chat with people who attended those courses, or even chat with professors if you can afford to do something like that. It's very hard to know upfront what to pick. Okay, running analyze data. Wait, what's going on? This doesn't look like we're doing, okay, we're not doing the right thing. We want to do dedupe analysis. I know that should be slower. That's how I noticed I picked the wrong one. Okay, while that is running, no worries. Just ask questions. That's the best thing you can do. Okay. So once we know which data sets tend to have a lot of duplicates, I think that's going to be useful knowledge for us later on. If there are some issues with some data sets, we know roughly, okay, that data set has a bunch of duplicates. it's problematic for that and that reason. That's a good information. For line lengths, it mostly makes sense to just understand what's the distribution across a particular language. But for duplicates, you want to know which data set, how many duplicates, which direction. So you need a bit more fine-grained info. Okay, well, while we're waiting for this to finish, let's switch our focus and let's see whether this NLLB MD was ever released. Oh, nice. And we found it immediately. Nice. So, unscripted chat. They mention unscripted chat, health and news. But what happened with scripted formal speech? Not sure. Let's grab this. By the way, Nick, join the server. A ton of people there are obviously interested in AI, so you can find likely-minded people. Maybe we also have like a reading group for NLP on Stanford. It's a Stanford course, that's what I mean. So you might be able to find peers there and see whether you get interested. So I think that's the best way to learn. Find community, do stuff your own. Yeah, just do whatever you think makes the most sense for you now, but try and just explore as much as possible in the early days. Let's download this data. Let's analyze what's going on in the NLLB dataset. I mean the multi-domain one. Languages are weird. The language choice is Aymara language. I don't even know how to pronounce these. Bhojpuri, Diala, Friulian, Russian, and Bolo. Okay, let's go here. Let's navigate. We're in FairSec. Let's just run. Actually, let's go to dataset. Wait, why not go to download data and just add download NLLB MD directory, and it's going to be the same as this here. Just copy paste this. NLLB MD. Okay. And then we just name it like this. And then we just grab a couple of URLs. Here's the first one. Here is the second one. Here is the third one. And then we basically just rinse and repeat exactly, and then do this, and that's it. Let's just change this to this. New URL. And now let's just download this data. Let's comment out everything else. Run this. Should make sense, right? Download URL, we get the data, we download it. We download it to basically let's make it like this. Let's do it like this. We grab the URL, we split on the slash, and we grab the last piece. And then we make that to be the zip download path. We write data there. Then we extract from the data. We remove the original file. And then we have to see what's the format here. So let's go here. Hit F5, no arguments. No snap. We need the download primary data script. Actually. Hey Marcus. Oh, really? We met in Tirana. Nice to see you, man. Yeah, I remember. You're from Germany, right? Long time no see. Akash, what's up, man? You see 22 download. Are we going to for full 200? I'm not sure what you're referring by 22. These are data sets, not, and some of them contain more than one language. Nick, no worries, just keep it up, man. Join the server, people will help you there. We also have interesting events. We'll have like people like director of machine learning at Cohere, which is one of the best current AI companies, joining to give a talk. So it's gonna be fun. Let's run this. Let's go through the URLs, download this, download path, raw data. Let's see how that looks like. So here's the MD. Here's the MD chat. Once we extract this, thanks, Nick. Don't spend any more money. Again, if you're a student, I appreciate it, but yeah, thank you. Chat. Okay, so now we remove the original zip and we go through dataset directory. Okay, the format here is a bit different. Test, and then English, Latin. So everything is in BCP47, but the format is test dot, and then two codes followed by suffix, which is also a code. Okay, so let's see. Let's see here. We can't have the met one. So what we need to do is grab the file name, extract just a suffix. Okay, so let's just do it like this. delete this, grab the suffix from the file name, and then the new file name is basically the corpus name followed by the suffix, because that's the format we always use. And then we rename the original file with the new file name. As simple as that. The only additional thing is we have to change. Actually, let me see. This might be. Is this a parallel corpus or just a single language? Yes, this definitely looks like a single language. So then, do they actually, how do they combine these? Wait, this is English Latin. So what's the thing? We have train, test, and validation here. Okay, that's because thank you. Yeah, have a nice day, man, or evening. If you're in Macedonia, I guess. Trying to understand what's the format here. We have validation, okay, train split and test split. And then for test splits, we have, okay, bowl of English, bowl of Latin. So I guess that's how they're paired. Here's the, I've heard they're making a new Stephen King adaptation, blah, blah, blah. And then here we have Russian, English, Russian Cyrillic. And then again, okay, all of these are duplicates. Why did they? This is completely wasteful. Like these files are the same. All of these files are the same. Okay, so six directions, I guess. Multi-domain. Let's just go to page 110. That's where they mention the MD, and then they say with 6 languages. We hold 500 sentences in each language for testing, fine-tune in 2000, and use reminder for validation. Okay. In each direction, we fine-tune. I think they mentioned 6 directions somewhere. 6 directions, 76, 6. The following 6 languages, and they are literally translated. Professionally. Okay. Let's go. Let's just continue executing this. We can't do this type of renaming, so for now, let's just keep this like this. Let's stop it. Stop the run and re-execute and just download stuff and see how it looks like, and then we're gonna figure out what are the next steps. We won't be using this one for training either way. This one, well, at the end, we can probably just put everything into our training data set. Remove, and then let's go for the second one. Okay. News, extract the news. So here the news, and then remove, and then do the same thing again. And finally, we can remove that zip file and we're done. So health, chat, and news. So in a way, these are 3 separate data sets. Again, we have splits into validation, training, and test. Okay. Let's check the test ones. Again, 1, 2, 3, 4, 5, 6, always set 6 directions. And it's always English centric. And English is always the same. English is always the same. Okay. So that's something we can use for validation. Just to test for non-Wikipedia domains. And we can use Flores for Flores 200 for non-English centric directions as well. Okay, so this is, let me just separate it down below and say evaluation datasets. And I'm going to comment it out and uncomment these. Okay, and here okay. Let's download Flores 200. Let's make it, let's just automate the process while we are still waiting. Check out my Medium blogs, how to get started with machine learning. For example, this one. This is the best one I think to get started. Just like I recommend Coursera, FastAI, just a bunch of people you should follow, the whole mindset about how you should be learning. So maybe that's the best way you can start. Let me just paste you here. Let's find Flores. Here it is. So it has 202 languages. Let's download that one. Let's just prepare, while we're waiting for the deduplication to finish. Let me see where we are with the progress there. Okay, it's still running. Let's see what we have here. Toxicity, we have this one as well. No worries. Happy to help. Okay. Let's see how we can automate download of these eval datasets. Let me see what else we have on our list. I'm focusing on this while we're waiting for this. Let's see Flores, and then we can check out those other ones. So doubles the existing language coverage of Flores 101, given the nature of new ones, which have been less standardization and require more specialized translations. Okay. So this is how you download the Flores dataset. Okay, so let's add this to our automation, and then download of SPM. You can install this here. We primarily evaluate using this, and then SP Blue as well. And then here are the languages and the codes. And previous releases. So this one is strictly a subset of Flores 202 with some modifications for some of those languages. Some of them were improved in 202. So paper, download, read the blog post, okay. And then there is the Flores V1. And we can download that one as well here. I think Flores V1 was an additional one that we want to use because it was mentioned in the paper. Here is the Flores. Let's grab the Flores V1. Previous releases. Okay. So here is the link. Baselines. Okay, training the model. Okay, nothing else insightful there. Permissively licensed, common, Creative Commons, attribution, share alike. This is not the, this is a permissive version. Let's see for this one, what's the license for this one? I mean, we're gonna use it for evaluation, so we don't really care. Okay, and let's see here, what is this one? Okay, we've seen all this before. Cool. Let's find a couple of other data sets that they mentioned. So one was Flores V1. And then there are 5, 6, 7, 8 more. 7. Let me quickly go to page 108 here. Okay, 8 directions, 4 languages. I think they might have added 2 more languages, which means 4 directions. Okay. Let's download. I can maybe reuse some of these functions to do everything because it's literally the same logic. Let's just replace this with this. When you say analyze NLLB seed, Akash, what do you mean exactly? We did analyze the whole, all of the data we have. NLLB seed is basically professionally translated. There is nothing to be, like, it already went through a very high, stringent quality procedures from Facebook, Meta. So in that sense, all is good there. Okay, so let's go and download Flores 202. Just quickly reopen. Okay, Flores 202. Let me just paste in the URL. This is called Flores 202. Download. And then why not just put Corpus name here? Okay, and let's comment it out. And we're gonna do the same thing for Flores 1 here. Let's just run this one. Exactly, and comment out this as well as this. Hit run. Okay, let's create Flores. Let's download the data. And here it is. Then we extract. Whoops, what did we do? It's not a zip file. How come it's not a zip file? What? Oh, wait. Okay, it's actually a tar gz. So for that reason, just think. how do we paste them here, and then we open and then extract all like this. So this is how we should handle it. Instead, download path, star, extract, and then remove. Okay. Rerun. Oops. Let's first just stop this, rerun the download script, get to here, download it. Let's just delete the old one, and let's extract here. Okay, here's the data, and underneath it are the dev test, the dev and the dev test. Okay, that's Flores. We can remove this, and we're left with this. Okay, so again, I'm still not specifying any particular structure. Okay, let me just first quickly store the file here. Cool. Here we have, I'm gonna pickle this one. Okay, and then let's just save it. Small context switching here. Let me just do this. Here is the dictionary handle, and let's save this one. Can't pickle local object. What do you mean by a local object? Maybe because it's nested, it cannot pickle it. Okay, let's just save it as JSON. Can we do that? We should be able to import JSON, and then we'd open JSON, right, as whatever file, and then JSON dump into this, and we don't have the protocol. We can put indent port. Okay, let's see where we save that. So dedupe corpus, lang dir, this should be it. Here it is. Awesome. Looking good. For each key, we store a dictionary. Nice. This looks amazing. This is everything we needed to do the deduplication analysis, basically. We can basically delete the pickle file. And okay. We have the data. Let's continue analyzing it after the break in the next stream. And let's also wrap up our evaluation dataset preparations that we just started. So basically these tasks here, as well as these ones here. And then tomorrow or 2 days from now, we're going to start training. Okay guys, time for a break. Catch you soon. Let me just find my, where is my live stream window? Here it is. I'll be notifying you in the server. By the way, I got my first streaming donation. That was very nice from Nick. I'll post the update once I start streaming here. Roughly 30 minutes, maybe a bit less, until the next stream. So catch you soon, guys. Bye, Sergey.